Welcome back. Here in green, I've got the graph of a function. And for right now, I'm not terribly concerned about what this function is, though I will need the formula for this function as I work through this problem. Remember that I am interested to find the amount of area between the x-axis and the graph of this function. And now to make this a problem I can actually solve, I'm only looking at x values on a finite interval. Here I've chosen between x is 2 and x is 3. Now I mentioned in my previous videos a method I could try to use here where I can fill in this space with a rectangle. So here in blue is a rectangle. Rectangles have a nice area to compute. In fact, this rectangle has a base of 1, so all I really need to know is the height of this rectangle. And I picked this rectangle to have height exactly 1.687. Why did I pick that height? Because that is the value of my function at x equals 3. That way, this rectangle fits underneath the graph of f of x. I could have changed the height. I could have picked, say, the height of this rectangle is 2.66. So what would that look like? Something like this. And I would have a rectangle that represents too much area rather than not enough. And I was saying last time that I can get better approximations for this area by using more rectangles, by using 2 rectangles instead of 1. I have less error here. Less is missing from the actual area I'm interested in. Or if I'm coming in from above, I have less extra than the area I'm interested in. As I go, I can use 3 rectangles instead of 2. I can use 4 rectangles instead of 3, and so on. And it looks like these are giving me better approximations. There's definitely less empty space here as I take more and more rectangles. But the problem that I'm having is that I need to have a formula for how to add up the areas of all these rectangles. It's one thing to draw the picture, but I really do want to have some kind of number here. And Desmos is not doing me any favors because Desmos has not drawn the boundaries of these rectangles, just leaving it to imagination. So in my Zoom window, I can annotate here and just put in those vertical lines that Desmos decided that we do not need. And forgive me if they're not completely straight. I've never been too good about that kind of stuff. What is the area of an individual rectangle here? Let's just figure out one of them. Well, I need to know 2 things. I need to know the width of each rectangle, and I need to know the height of each rectangle. Here I have 10 rectangles filling up an interval of width 1. They all have the same width, so each of those widths has to be 1/10. And now, how did I pick these heights? Well, I told Desmos to do it, but how did I tell Desmos to do it? how did I know which values of the function to use? Each of these heights is the value of the function somewhere. The smallest of them was at x equals 2.1. That was my smallest x value. And every time I went out, I increased by 0.1. Is that a mistake? My rectangles are width 1/10, and each rectangle has height determined by x, where I'm moving over by 1/10 every time. Oh, wait, no, that's not a mistake. That's on purpose. So starting at 2.1, the height of this rectangle is going to be f at 2 point what? 2.1, 2.2, 2.3, and so on. Oh, I have a formula for that actually. If I'm moving over by a certain number of tenths, then this rectangle has this height. So an arbitrary one of these rectangles will have width 1/10 and height, the function evaluated at 2 plus k divided by 10.